with us today, experts from different domains of the energy world. I have with me today Mr. Rajan Varshney from NTPC, Mr. Subba Rao from NDIGH, Ms. Vijya Chitk from EIL, Mr. Vijay Kaul from Ratnamani, SEAL, Mr. Shabareesh Nair from Tubacex, and leading and moderating this panel, we have with us Dr. Aruna Sharma, who is the former Secretary Steel and now a practitioner, development economist and independent consultant in the energy world. I'll hand over the dais to Dr. Aruna, and I'll ask all the panelists to please join us on the stage. Please join me in extending a very warm welcome to the panelists. I'll hand over the stage to Dr. Aruna now and request her to initiate the proceedings of the session.
Good afternoon, and this is the most difficult time post-lunch, but I'm very sure the kind of topic they have said is something so futuristic and so exciting that I'm sure it'll keep you awake and it'll ensure that it sails you through when you're going through, ahead with it. We are all talking about the green energy, climate change, everything, and it's such an abstract concept that it is not something visible in front of us. If it rains heavily, we say, oh, it's climate change. If it's too hot, we say it's climate change. If anything happens, or if you see the pollutants going up, you say it's going to have adverse impact. But we are not understanding exactly how we are going to go about it, or to what extent we have to walk the way to reach. And when I say that, there is a conflict between the commerce as well as the technical corrections that are needed. When we are talking about it, coal, we have ample with us. So for anything thermal, we are dependent on coal, and I think another 40-45 years, it is there. During pandemic, the entire world went on a reverse gear, who were thinking to put the sanctions and putting a penalty if you're not following the carbon footprints and the acceptable percentage of carbon emissions. They all opened up their coal mines, starting from US to Europe and down the line. So in the sense, this particular agenda has been put on shelf, but that does not mean that it is going to stay there for long. The talks are there, the G20 is also talking about it. Everywhere it is getting flagged, and that's how it is going to go for it. So looking at this particular session is looking at three alternatives. One is, of course, the oil and gas. Oil with the reduced emissions and gas as a better alternative for both the automobile sector as well as the industry. Then we have ethanol, which is the bio alternative. To what extent we can do, and Government of India has walked a step of making a percentage mandatory to be mixed with oil, fuel oils, while we are operating upon it, to what extent we will be capable of doing it, commercially viable at lesser cost and quantity. So that is the challenge we are going to face. And third, of course, when we are talking about on the alternate energy, is the alternate energy sources, where the hydrogen gas is being debated and talked about, still at the research stage, still at a possible stage, still at a battery cell stage, where the two-wheelers are operative or three-wheelers are operative, but whether in a commercial way as a pipeline, whether we should be in a position to go. So these are the challenges that we have, and I have got very eminent, experienced panelists with me. So what I suggest is that we have nearly 1.5 hours with us. So I'll request each of the panelists to restrict to 10 minutes, if it's okay with you. And then we have another 20 minutes for questions and answers from the audience, if any, and then we can go ahead and proceed upon it on this very, very futuristic topic, but something, a mandate, which will be straight on your table when we are moving ahead with it. So I think, how do we start? Okay, I start with Mr. Subba Rao, who is with INDIGH. Yeah. And Mr. Subba Rao, if you look at these three alternatives, do you think commercially, in a short-term span, it is possible for us to go ahead with this? So whether we are looking at the research angle of it, whether you are looking at the commercial usage angle of it, and whether we are thinking of the shift angle of it, how much it is possible, and among the three, in which way you will like to rank them? Over to you.
Thank you. I'm going to talk about its commercial angle. So in last year, COP22 in Paris, world leaders took a decision that to decarbonize the world, it is essential for us to adopt green hydrogen. Now, it is estimated that in India, by 2030, we may need 5 million tons of green hydrogen. 5 million tons. That means that a huge amount of electrolyzer requirement is going to come up. Already Adani, Ambani, many big industries are already onto manufacturing electrolyzers. How it is going to help the stainless steel industry, I will tell you. In electrolyzers, the cathode which is used in that is made of stainless steel. I have come across one company in Greece which is manufacturing entire their electrolyzers with stainless steel 316L. Here in India, we may need bigger electrolyzers which manufacture 2 tons per day, 10 tons per day. That kind of requirement is going to come. The stainless steel that is used there is now being electroplated with nickel. Because straight away using stainless steel, because of its chromium present, it is going to be consumed in the water and chromates are being formed, which is not acceptable to Pollution Control Board. However, looking at the enormous market that is going to come in the next, not 50 years, just 6 to 7 years, stainless steel requirement is going to be very, very huge. The industry has to see what is that these stainless steel can be produced, which is electrolyzer friendly. Electrolyzer friendly means less chromium content or zero chromium content. Is it possible to produce stainless steel? Because in one typical 1000 meter cube, that is 2 ton per day, hydrogen producing electrolyzer, there will be minimum 15 to 20 ton of stainless steel. The stainless steel cathode electrode is going to be totally that much. So we have to see that we have to get ready. The stainless steel industry now, I was listening to the panelists in the morning, they were thinking of where is the market. Should we, construction market, should we request them to open up? Now, whether you ask or not, stainless steel market is going to be a multi-billion-dollar industry in India in the next 5 to 6 years only. You have to speak to industries who are going to manufacture the electrolyzers, what kind of stainless steel they want. What kind of composition they want in the stainless steel. This will increase because it is also estimated that in India itself, the green hydrogen is going to add at least $10 trillion to the GDP. $10 trillion is huge. The industries that are there right now manufacturing stainless steel will become minuscule. We need bigger industry to manufacture stainless steel. That will be this one, because green hydrogen, right from your drinking water to the petrochemical industries, it will be applied everywhere. If you want to decarbonize, we are now applying this to cement plants to blend green hydrogen into their kilns, to steel industries, aluminum industries, power industries, wherever there is a furnace, there we are advising them to inject green hydrogen, which means that the production of green hydrogen is going to be huge. Which machine is going to produce? It is electrolyzers. Electrolyzers, invariably they want electrodes. These electrodes are made of either stainless steel or titanium. Titanium is very costly. And right now, because stainless steel is not fully viable, they are using platinum coated titanium as electrodes, which are very, very costly. That is making electrolyzers very costly, and production of 1 kg of green hydrogen is also very costly, somewhere around 3,000 rupees per kg. It's huge. Mukesh Ambani once told that I will bring down this cost to 100 rupees. He will. I know. I was paying 500 rupees per GB of data. Now I am paying less than 5 rupees. It will become, electrolyzer market will become commodity in the next 10 years. But consumption of stainless steel will be mind-bogglingly huge. For this, the industry has to get ready. They should invest in R&D to what kind of user-friendly, green hydrogen-friendly stainless steel they can manufacture. What is that the industry requires? Because whether we want or not, the world is going to go in green hydrogen way.
Thank you so much, Mr. Subba Rao, for setting the ball rolling in the right direction. The industry per se is ready to accept the hydrogen gas the moment it becomes commercially viable. The GAIL has spread the gas pipelines, so the veins are there. It's only a question of natural gas supply versus to that of shift to the hydrogen gas supply. And when we are doing the hydrogen gas manufacturing through electrolysis, it is going to be decentralized. So it's not going to be centralized plants. So there'll be lots and lots of plants coming in near vicinity, and that will require definitely more and more processing of electrolysis. And what Mr. Subba Rao is correctly flagged is you have to start off from the research point. You have to come up with the quality of steel. And here I'll just give you a small example that when the rails were put, it was the RDSO of the railway department which used to say that futuristic, we are going to use this product. And then the steel makers started working upon it. So here for stainless steel, that is the opportunity where experts like Mr. Subba Rao has opened the bag in front of you, telling you less chromium required, nickel plated required. So how are you going to manufacture that kind of a material which is going to help for better electrolysis and compete with platinum or titanium coated materials, which definitely are expensive and have to be imported. So that's a challenge. Thank you so much for putting this on the table. Now I request Dr. Soya. I think we have Mr. Pal is there. Yeah, Mr. Pal is there, that's right, who is from IOCL. Now, if you look at the IOCL, it is something, our dependency on oil, our imports on oil, our imports on natural gas. But if we have to come down to carbon content, this becomes like a mandatory import. So I will request you to sort of how we navigate through this and to what extent we can be indigenous about it and to what extent we will continue to be import dependent. And as far as the steel industry is concerned, it's an option between coking coal versus natural gas. So both you have to import, so maybe a natural gas is a better product. Over to you, please.
Good afternoon. I'm Mahendra Pal. Actually, I am from refinery background, and recently I have joined the Research and Development Center of IOCL. I'm basically a metallurgist, and I have all through worked in the field of inspection, corrosion engineering, and materials. So, regarding this question, that the importance of oil per se, it is going to be there because overnight, if you think that we are going to change over to gas or hydrogen or other fuels or totally convertibles of what you call the green fuels, it is not going to happen overnight. So the thing is that the oil is going to stay, and only thing the basket is going to get changed over a period of time. Like say for in another say 30 years, maybe we'll have a blend where we'll have oil to a very minimal composition, and it will be more of renewables in the form of gas. It can be form of hydrogen, it may be form of solar, wind, and so on, nuclear for that matter. So going by this philosophy, and IOCL has also taken an internal, what you can say, decision to go green, say, by say 2040, 46. So 46, we have kept our internal target that we might reduce the carbon to the extent possible, and that is the commitment that our management has given to the government or ministry, you can say. So now coming to what exactly we are doing in that case. So regarding the refineries per se, so what we have done is, over a period of time, you will find that in the refineries now, instead of burning the oil, earlier we used to burn oil in the furnaces. So now that has been replaced with more or less gas. So now it is more of gas burning. There are so many advantages of gas burning in the refinery furnaces. Like one, you reduce the SOx, NOx or the carbon emission. That definitely is less. Now, if you burn more of, say, natural gas or you can do the off gas. So those type of hydrocarbons are relatively cleaner compared to the fuel oil, which has enormous amount of, you can say, sulfur and nitrogen and all that. So that's number one. Now, coming to hydrogen. Like in the refineries now, there are several routes of production of hydrogen. One is your hydrogen is made with the help of, say, naphtha or RLNG, and that is made in a hydrogen generation unit. Typically, you have what you call the licenses like Technip and the licenses are available. So that is number one process, and you reform it in the presence of catalyst in a reformer furnace, and then you have this, what you call the hydrogen coming out, and that you purify it further and then you put it into use wherever inside the refinery or outside. Or then coming to other thing is now what you call the green hydrogen. Just now one of our esteemed speaker was telling about that. So in that process is basically nothing but you can tell it is basically an electrolysis. So one such plant is also coming in our IOCL also. It is coming in near Panipat. And another one, earlier it was, one more is going to come at Mathura. So, but the Panipat plant has been approved. So, maybe in near future, you will find that the plant is going to come up. And basically based on the electrolysis, as our esteemed speaker was telling, that because it's an electrolysis process, you will need electrodes. And there, of course, you have this, what we call stainless steel and titanium thing. Because you have to subject to that electrolysis where you will see a lot of corrosion and other activities happening. Now, coming to the potential of stainless steel, how the refinery and petrochemical industry per se requires a lot of stainless steel. The reason being, so once the project, say any project is what you call conceptualized, in the initial stage they generally see that the project is viable or not. So viability comes by how? So they will do all that cost economic analysis, and then they'll come up with some IRR, MIRR, that if a certain number is there, and then the project is viable. So many a times what happens is that to make the project viable, they go for a cheaper and what you call material. So where say for example you are supposed to have stainless steel, okay, they may compromise with say carbon steel or say alloy steel, which can serve the purpose. And then what happens is once a plant is commissioned, and then after an operation of say 2, 3, 4 years, 5 years down the line, then you will start seeing corrosion and other things happening, and then you will start replacing the material. And many a times what happens is the corrosion or the corrosion process itself is such that there is no better metallurgy than a stainless steel. I'll give a very classic example. People from the refinery background, maybe they will appreciate this, that there's a process, there's a unit called hydrocracking unit. Hydrocracking unit, that unit, basically the purpose is, what it does is, it will take the heavier cut of a fractionation column, it will process into and convert it into useful like diesel, MS, gasoline, that type of conversion it does. So in the process what happens, there's a stream called effluent that comes from the reactor. So that effluent comes from the reactor, it passes through air fin coolers, and then it goes down to the other units. This effluent air coolers, so these are all high pressure air coolers. They operate at 170 bar, 170 kg sort of. It's a very high pressure. These are generally carbon steel material at most of the places. But what is happening over a period of time is that these these air fin coolers or the high pressure equipments, they have started failing. Why it is failing? Because if you track back, the root cause that comes out is that now whatever crudes that we are processing, that crudes basically, those crudes contain a lot of chloride. So chloride, why these chlorides are coming? Because once you start extracting more and more crude, over a period of time, what is left in the well, they get more concentrated with lot of chlorides and other impurities. Now these impurities, when they carry over to the refinery side, they start corroding and creating lot of nuisance. So to take care of this type of material, now what is that? Well, you have to use a material which is more more resistant to such type of failures. So naturally, where we have to look to? We'll have to look to materials which are superior, like the stainless steel or your Inconel 625, 657, and those are exotic type of haste alloy. So these type of materials, these are now being the existing equipments are being now replaced or upgraded with this advanced materials like this duplex stainless steel, or you can Inconel 625, haste alloy material. These are all very high end and very costly materials. So so here we can see a lot of potential. Earlier with the equipment which are of carbon steel, now these equipments are being replaced or upgraded with stainless steel or higher austenitic grade materials. So here we see a lot of potential. Now coming to another dimension of refining, because refining over a period of time is definitely it is going to it is going to slow down. And what refineries or refiners are doing now, what they are doing is that now they are converting their existing refineries and integrating it to petrochemicals. Now refineries, they in future would become feed preparation unit for your petrochemicals. So now coming to petrochemicals as such are very exotic type of process units where you will find different type of corrosion, and to tackle this type of corrosion itself you need advanced materials, or you call sophisticated materials, ranging from your stainless steel, titanium, and even more higher like your microalloyed HP modified, and those type of grades which are mostly you can tell stainless steel or they're superior to stainless steels. So what I understand is that seeing this opportunity which is coming in future, there will be a lot of scope for stainless steel and higher austenitic grade materials, and I think that there will be a lot of market for the stainless steel to come in future. I think with that I would conclude. Thank you.
Thank you so much, Mr. Mahendra Pal. He has talked very, very important two things to be flagged. One must be on the lookout of their experiment of using the electrolytes for the hydrogen gas production for their in-house use, because that will enable to work out the costing, that will enable to the shift to the usage where many of the plants manufacturing who want to reduce their carbon footprint can target upon. And second thing he has talked about, that how you can go ahead for replacing the carbon steel with the stainless steel market. Now, in the general financial rules where the acquisition takes place, the word life cycle has been inserted. So we did it in 2017-18, and what it calls about is life cycle cost. The moment you say life cycle cost, stainless steel will be the winner here vis-a-vis the carbon steel, because the maintenance which is going to go for corrosion and replacement cost is going to be very heavy. And what he was talking about, it only takes a couple of years to get corroded and requires a replacement or requires a correction. So this is where you have to be alert, and all stainless steel manufacturers as well as the refinery persons, you should be aware about the clause of life cycle cost when you are a decision maker. And the stainless steel makers, you have to constantly educate them with the kind of products that is available or you can manufacture, you can supply, and give that kind of a clearances from them on the quality of the pipeline of the stainless steel that you can provide for. Thank you so much, Mr. Paul, for this. Now I think I'll go to NTPC, right, where maximum carbon usage and what could be the alternative for it. Yes, Mr. Rajan, Varshney, over to you. Because NTPC, yes, we are coal dependent, We look forward for 50 years of coal dependent as 50 years for oil dependency. We don't see an escape route from there. So Mr. Varshney will tell us what could be the escape routes, what could be the benchmarks. Over to you.
Yeah, I work with NTPC. I'm looking after new initiatives. My experience has been mostly in coal-based, but in last 10 years, I have been in renewables, hydrogens, and further conversion of things like which can avoid use of coal to some extent. So I would like to discuss more on those things because to avoid repetition also and to give food for thought for steel industry also, how they can decarbonize steel also. 1 ton of steel presently releases about 2 ton of carbon. But if we produce green steel, we will be able to get the export market captured very easily because India has a lot of sunshine available and various techniques are available here. If we can collaborate with research institutions and startups and industry, proper collaboration is there, we can have hydrogen at much lesser cost. And this hydrogen is the thing which can give us low carbon steel. Because hydrogen is used in various forms, like in DRI also, you can use hydrogen for reduction of iron ore, for pelletizing also, in blast furnace also, in annealing also. Wherever heat is required, strong heat is required, we can use hydrogen. Wherever electricity is required, we can again produce electricity through hydrogen. Now hydrogen has to come at lesser cost. So green hydrogen is simply not that if we use electrolysis, it will be hydrogen. It will require a lot of water. 1 kg of hydrogen requires around 20 kg of water. You have to purify it and 9 kg is required, deionized water is required for producing 1 kg of hydrogen. So we have to go into, like IIT Madras has, even our NTPC research also has developed a system where we can use directly seawater for electrolyzers without even purifying water. Because even in alkaline electrolyzer or PEM electrolyzer, we have to put some salts to have the conductivity between the electrodes. Now, if we can have the electrodes made in such a way that they can withstand corrosion of seawater, so easily we can do that. So this is one way where we can use even seawater also or wastewater also for producing hydrogen. Now, second thing is, like Madam said, dependency on coal. So wherever we have these PV, photovoltaic solars or wind based turbines, they produce electricity, but again it is intermittent and the capacity factor is hardly 20%. Because other times in solar you won't get sun, sometimes it will be dim, sometimes cloudy, sometimes fluctuations. Similarly in wind also, maybe at night time you will get good wind, but at many locations you will not get even good wind during night also, what to talk of day. So all these things produce renewable electricity, but also in manufacturing those panels or the wind turbine components, we are causing carbon emission. Then in recycling those or dumping those, again there will be effects. So to control the intermittency and to avoid the material usage for making those, there are many ways to produce hydrogen, and that green hydrogen can be cheaper also, like we can make it from waste. If we do simple pyrolysis or gasification of mixed waste, we can generate from that syngas. Then syngas can be purified and hydrogen can be extracted. Similarly, in pyrolysis also we can get hydrogen. Then there are other techniques that heat for breaking out hydrogen from the waste, because every waste has hydrogen in it. It is only we have to extract hydrogen out of it. So there are microbial techniques also. Even from industrial wastewater also, we can produce hydrogen through microbial consortia, which can break down those carbohydrates in that, inorganic carbon, organic carbon, and those compounds, once broken, these consortia have different microorganisms which can eat those or produce hydrogen out of them. So all this is like available and under development. So I would like even steel industry should produce their hydrogen, and through these means, which can be cheaper also, and also take care of environment also. Waste is a big problem. If waste is allowed to decompose like it is decomposing in many landfill sites, it is releasing methane. Methane is 84 times more potent GHG gas as compared to CO2. So if we can use fresh waste and use it to produce hydrogen and other things, it can be a win-win situation for everyone. You will get cheaper hydrogen, you will get it near the place of usage, and moreover, that landfill sites will get freed and no methane emission will be there, or very little methane emission will be there. Similarly, there are techniques where people are doing catching this methane and capturing this methane, and through biodigestion they are making methane from the wet waste, and from that they are splitting this methane. One technique is steam methane reforming, and in that CO2 is released, but that CO2 can be captured. And I'll come to that, how that CO2 can be used if it is captured. But if it is from waste and that biomethane we are using, then it is a renewable CO2 basically, which has been captured by the plant which we ate, and that waste generated and used. So overall CO2 balance remains, overall CO2 concentration remains same, because that CO2 itself is getting released once we are releasing that CO2 for making hydrogen from SMR. But the second thing is methane splitting. In that, through various processes, we can produce some byproducts which are much more costly than hydrogen. Like, we can produce carbon black, graphene. Graphene is a very versatile material, and it sells around 5,000 to 10,000 rupees per kg. If we consider it that way, we can say that hydrogen will be at negative cost. So there are ways and means to produce hydrogen at a cheaper rate, and if we concentrate only on electrolysis, we may not be able to go to that 80 rupees, 100 rupees per kg figure, because 1 kg of hydrogen production requires around 55 units of electricity. So if 80 rupees cost is to be reached, your electricity should come down to 1 rupee per unit. Then these balance costs of land, electrolyzer, and balance of plant things will be there. Now, one more thing, how we can avoid using coal or use lesser coal in generation of power. We have concentrated solar thermal technology, and I have been advocating it for some years. Now it has gathered momentum in India also. So instead of steel industries putting up their coal-based thermal power plants, if they start putting concentrated solar-based power plants, it can give them high process heat, high temperature heat also, as well as green power also, and that too 24 hours a day if it is done with storage, heat storage. And further, what it can be done is, it can be used to make the renewable power firm, which we call renewable, like only photovoltaic and wind. Because inherently these are intermittent, they are not dispatchable. We have to support them through coal or something. So here we can support them through concentrated solar thermal power generation, and it can be made dispatchable. And if we have, say, 14 to 16 hour storage, storage is very cheap. Like whole plant costs around 10 crore per megawatt, but for 16 hour storage, because basically molten salt is used, it is quite cheap, and maybe 2 crore per megawatt cost will be there. And if we calculate levelized cost of electricity, it will come down to hardly 3 rupees per unit. And the plant life, this I am saying taking plant life as 25 years only, but this plant doesn't have much moving parts. So it can continue till 50 years also. And glass is, can be made everywhere, even in India. We had the oldest glass factory, Asia's first glass factory in India only, in UP. So if we go through concentrated solar power route and concentrated solar heat route, and there is no point in converting various electricities, types of electricities into heat, when we can directly use the sun's heat for heating purposes. Now this, these have mirrors and lenses, and they can concentrate the sun's heat and reach a temperature of 1700 degrees centigrade, 1800 degrees centigrade even. Although for power generation we require only around 500, 600 degree temperatures, and because of molten salt storage we have to restrict them to 525 degrees centigrade, because molten salt has its, again, properties. Beyond that we cannot go. But this 1700 or 1800 degree temperature Celsius is required for direct splitting of hydrogen also from water without electrolysis, through photocatalyst splitting. So this is my discussion on hydrogen and how to avoid coal and how to replace other sources. Now one part is, I had said that CO2, if it is captured, how it can be utilized. We are also doing some implementations on that. CO2 can be converted to ethanol, methanol, and other fuels, SAF, and like if we do double electroreduction of CO2, we get ethanol. So all these techniques are reasonably developed. They are at TRLs 5, 6, 7 levels, and the need is to increase their usage. And in various industries, if we go for this, India is not at all behind the world. We are very much at par, or maybe in some areas ahead of the world. Need is to capitalize on it. Thank you.
Thank you so much, Dr. Varshney. He has taken us back to the basics of physics, chemistry, to understand very well that you have to go back to basics and try out everything if we are thinking of reducing carbon emission. It's not just one answer doesn't lie in one place. When you are looking at renewable energies, it has limitations, but there is an answer for it, where he has talked about, like this is the first time I'm hearing about concentrated solar-based power plants. Now, this is something, I don't think so it has been in the public debate at all. So that has to be sort of brought out, because that is where the renewable energy is brushed out, that it is inconsistent, and therefore the plants cannot depend on them.
Actually, I may add, these plants are running across the world for last 20, 30 years.
Very right. But here it
Yes.
doesn't
In
seem to be
India
at the
only-
center of debate
yeah.
at all.
Yeah, in India, what happened? Just let me tell you the history behind it. In Jawaharlal Nehru solar mission, bids were called for both types of electricity, CSP based as well as PV
Much
based.
nearer.
CSP based as well as PV based. In CSP based, the winning bids were around 12 rupees 20 paisa per unit. And in PV based, it was 17 rupees 50 paisa at that time, 2010-11. But CSP bids were never called again, and these bids were called again and again, and we kept on importing solar panels from US, then from China, and then from other countries, and now the cost has come down to 2 rupees.
Very true.
Or even less than 2
Very true.
rupees.
Very true. Less than 2 rupees, like.
Need is to go into that and utilize this technology. The
Very
reason is in many foreign countries, sun is not available or available only, say, few days a year. But in India, we have to adopt the technologies which are good for India. We have 365 days of sunlight.
Very
We should
correct.
use this
Very, very
technology.
correct, Dr. Varshney. Thank you so much for bringing it center stage and also flagging out the use of ethanol, where we can create either by biofuel or by the chemical process, whether we can create that methanol and ethanol and everything. And he has also cautioned against the emission of methane versus carbon. So that's another danger. When we go blindly for it, we are able to face it. Thank you so much, Mr. Varshney. Now I request Ms. Vijaya, who is with the EIL, for her composition, because when we are talking about stainless steel, the advantage of stainless steel and how these alternate fuels will need stainless steel. Over to you.
Thank you, ma'am. Good afternoon to all. First of all, I would like to thank ISSDA for giving us this opportunity to be the part of this panel discussion. My name is P. Vijya Chitk from Engineers India Limited, and I am accountable for materials and corrosion. So today I would like to give a talk about, green hydrogen. Hydrogen is often touted as a fuel of future, as an energy carrier. Talking about the green hydrogen, as a feedstock, it is used in sectors like refineries, fertilizers for production of ammonia and urea, and the chemical sectors. And as an energy carrier, it is used in the pipeline for natural gas pipeline or in the power generation. So in net zero economy, green hydrogen, it is a dominant use as a feedstock and as an energy carrier. In refineries, if we see in 2018 to 19, around 5.5 million tons of gray hydrogen has been used. They have consumed oil refineries. So green hydrogen can be substituted in place of the gray hydrogen. To produce green hydrogen of around 5.5 million tons, we need round the clock of 115 megawatts of power and 15 billion tons of fresh water round the clock. So to produce the green hydrogen, actually green hydrogen is produced through the renewable sources and by the process like electrolysis, photolysis, or the gasification, biomass gasification. So to produce the production of green hydrogen, and then the transportation, if the green hydrogen can be transported through pipelines. Nowadays we have a study, we have carried out a study that the percentage of hydrogen to be blended in the natural gas in the existing natural gas pipeline. There are available codes which says for carrying hydrogen, 100% hydrogen, and also for the conversion of existing pipeline to the hydrogen pipeline. So if we see the amount of hydrogen to be blended in the natural gas, we are carrying out the study for that, because hydrogen, what it does is, if it is a new pipeline, then there are codal requirements. For the existing pipeline, there may be the probability of pre-existing cracks are very high. So if we blend the hydrogen in the natural gas, these pre-existing cracks, it will decrease the fracture toughness of the existing carbon steel material. Mostly all the pipeline materials are carbon steel, and it will reduce the fracture toughness of the carbon steel material, and there the embrittlement, that is a hydrogen embrittlement, it will occur. So hydrogen embrittlement is a technical challenge for the people how to eradicate this hydrogen embrittlement. So we are carrying out studies, and we have collaboration with the educational institutions also to determine the percentage of hydrogen to be blended in the natural gas pipeline. And if we see, there are so many types of hydrogen there are in the market, like gray hydrogen, green hydrogen, blue hydrogen. There the color differentiation is from the sources of the hydrogen, how they are produced. And we are on the production front, from EIL, we have collaboration with various educational institutions where they are carrying out the studies to predict the hydrogen embrittlement through the finite element method. And there are various methods which we are carrying out the studies with the educational institution, both the laboratory studies and the simulation studies as well, to predict the hydrogen embrittlement in carrying the hydrogen through pipelines. Thank you.
Thank you so much, and she has flagged, thank you so much for flagging this, because logistics is a big challenge even if we succeed in producing commercially viable hydrogen. And very correctly flagged that the existing pipeline needs education to institutes like GAIL, who is responsible for spreading, to shift the material of their pipeline to stainless steel instead of carbon steel, which is we are existing, because in future, after blending the intermittent stage with natural gas, ultimately it will shift to maybe 100% hydrogen gas.
Yes, integrity of the material, pipeline material will be affected.
Absolutely, absolutely. Thank you so much for flagging it. Thanks a lot. Now I'll request Mr. Vijay Kaul, who is General Manager with Ratnamani, and with his expert background on oil and gas, I will like him to focus upon stainless steel versus oil and gas. Little bit was touched by Mr. Paul, but then what is required is how this shift is going to happen and why it is mandatory rather to have this shift. Over to you.
Good afternoon. See, oil and gas, as we have been discussing, would continue to be the fuel for the future, at least for next 3 to 4 decades. And most of it, why stainless steel is important, is because it is corrosion free. So that is the most important aspect for using stainless steel. And we at Ratnamani could envisage that usage of stainless steel 4 decades back, and came up with the facility to produce stainless steel. And as you go into the oil and gas sector for future, where refinery and petrochemical complexes are coming up, we would need high-end alloys like nickel alloys, duplex, super duplex, and the capacity to manufacture and capability to manufacture that. What we observe is that if you take up the quality of the product, which is very, very important, the life cycle cost, as we discussed, we find a lot of threats coming over from the low-end manufacturers from China, where the quality of the product is not very good. So we would, what we desire is the people who design these products, like Engineers India Limited or IOCL or BPCL, they should take life cycle cost into consideration before designing the product. Because as we say, stainless steel should have at least a minimum of 30 to 40 years of life. And the downtime for a refinery is very, very important. So what we suggest here is we have now put up the capability to manufacture stainless steel tubes and pipes up to 10 inches, which was never there. But this was forcing the demand for expansion in the refinery, in the oil and gas sector, into the LNG business, into the hydrogen business. So we can manufacture all types of products which are required for this industry. And we've been supportive of it for quite a long time. So because he has mostly touched on all.
Yeah. Thank you so much, Mr. Kaul. And very rightly he has said that anybody who is in the refinery or petrochemical industry have to understand that life cycle cost calculation is now mandatory. So it's not an option that, okay, I will not go for it and I'll go for the cheapest material, which will be carbon steel. Answer is no. So if by research, by quality control, stainless steel, your product is flagged, then it is a mandate to go for it. So please flag this to everybody whom you're coming in touch, to your clientele when you're moving ahead with it, that this is the material they will have to target for, and it is to their advantage. And you can help them to work out a code in case they don't have. And the life cycle cost calculation assistance, because if you give them a ready-made material, it will be helpful for them for a decision arrival. So that will go a long way. Thank you so much. Now, last but not the least, we have Shabareesh Nair, who is Director Technical with Tubacex. Very important field, and this is where the alternatives to the traditional way of material usage as well as to that of energy usage. Over to you.
Thank you, ma'am. It's my pleasure to be a part of this panel, and I don't know, I think most of the topics have been covered, and I've learned so much in this might be 1 hour discussion, and I believe that a lot of information has already been put across, but what I would want to share is might be a global perspective. I come from Tubacex. We are a Spanish multinational. We are a steel mill, but of course we are also looking into various solutions for hydrogen, also for other applications. If I talk about as Tubacex, we have traditionally been in oil and gas, has been a forte. Still more than 60% of our sales is focused towards oil and gas. However, we also see a transition. And that's where we have come up with our low carbon solutions. And what it means is that the existing applications where we are servicing, for sure, those are not going to just die off. It's going to remain. So we need to also have solutions which will come up with low carbon alternatives. One of the applications that we are quite focused upon as a group, we in fact have the second largest market share for that, are the products that are used for oil and gas exploration. Typically, we used to even report internally as products for oil and gas, and now I think we have split it into oil and gas, which means that we report oil differently and gas differently. So that shows the importance about how gas as a low carbon alternative has been evolving. And one area that we are seeing a lot of movement globally is, I think Sir touched upon the carbon capture part. So we have been working on a couple of projects in America, wherein they're talking about carbon capture and storage. So the products that we were using for taking the oil out or the gas out, now the same products are being utilized for storage purposes. So beneath the seabed, you have the old depleted wells. So we are having similar products, and here the portfolio is just changing because you're talking about CO2 coming in, you're talking about high pressures, you're talking about high temperatures. So super duplex as an alloy is evolving. And we are also working on a couple of projects towards this part of the world, wherein the similar storage technique has been utilized. So that's one area we see where existing business is still remaining. It will not go off. And I think Mr. Pal touched upon the REACT application or the reactor air fin coolers, which I think everyone knows. A couple of years back, there was a huge fire at the BPCL refinery. And everyone knows what the reason for that. So alloys like, as he mentioned, Inconel 625, it started with duplex, then it moved to 625, then 825. So all these alloys have been evolving. However, I also want to touch upon the point that material selection always gives you an alternative of a new alloy. But it is also important, which Mr. Kaul mentioned about having it sourced from the right people. Sometimes I think material selection also is a challenge wherein, let's say you go for a high alloy and it fails, and then eventually the terminology is that this alloy is not suited for this service. It could also be that it was not made properly so that it failed. So that's also an angle which eventually goes to life cycle cost part which Madam has been deliberating upon. Apart from this, I think what I was also thinking when we were all talking is the three topics that we have, which is oil and gas, ethanol, and hydrogen. There are conferences which are happening on each topic differently. And we are combining all three in a 1.5 hour speech, but I think it's a big challenge for Madam also to bring all thoughts together. But I also want to ponder upon hydrogen. That's also something that we as a company have been working a lot on. And it is not only for giving products, but also as a steel plant, how can we incorporate these technologies to produce green steel, as Sir mentioned. So we are working on technologies internally, also to align our processes so that we utilize a lot of hydrogen. We have a lot of furnaces that we use for heat treatment. So converting those from, let's say, a gas-based to hydrogen-based, that is a project that we are working on. So we also would intend to contribute to the net zero requirements that are there. Apart from that, as Tuba says, we are working on a lot of technology projects. One which I would want to highlight is, I think Sir just touched upon that, is waste to hydrogen. So the European Innovation Fund has allotted $400 million, wherein we as Tubacex are working with a lot of technology companies, and we have developed a technology for waste to hydrogen. It is not new. I think Sir already spoke about pyrolysis. What we are doing, we come from a material background, so there are materials which would be required which can suit those conditions. So we come with the material background, and with collaboration with various technology companies, we are setting up a plant in Bilbao, from where we come from, a pilot plant, and the idea is that this technology should evolve. So if I say hydrogen, what we feel is that it is not going to be one color. I think Madam mentioned about the various colors. Now I think we have a big bureau of colors. I think every color there's a hydrogen. In fact, I just on light note say that every conference I go, I find a new color of hydrogen. So it's quite interesting the way it is moving, but eventually I think what we are all doing here is to promote the hydrogen economy, which I think is the end goal. What we feel is that green hydrogen will be a good entry point, but eventually all forms of hydrogen will coexist, and that is what is going to help us to get into the portion that we want to go, that is net zero. Apart from that, we have some solutions towards hydrogen from material perspective. Especially coming from the aspect of storage and usage. If I talk about specific applications, it could be linked to automotive, it could be linked to storage in form of cascades, high pressure tubing coming into picture. Apart from that, we're also proud to be mentioning that the hydrogen ice that Ashok Leyland developed along with Reliance, we have been proud to supply our tubing for that. In fact, Reliance also developed a technology with Bharat Benz for hydrogen buses, and we are also proud to be a part of that project. So, as I think Sir mentioned that in India there are things which are happening at different levels, at different areas. We speak about hydrogen at every, I will say, area of application. And as Tubacex, we are contributing in each and every way possible so that we can, I think, make eventually the goals clear. One last point I want to touch upon is, I think, Madam, you mentioned that hydrogen is not going to be like made at one place and transported by huge pipelines. So the concept of hydrogen hubs is something which is evolving. And we as Tubacex are a part of an alliance called the India Hydrogen Alliance. It's called IH2A, wherein we are also advocating with the government for the concept of hydrogen hubs. So it's been very proud to mention that the first hydrogen hub project is being discussed with the government of Kerala, and they call it the Kochi Hydrogen Hub, and that is going to be the first hub that is going to be developed. Along with that, there are discussions happening with the various state governments. Everyone is coming out with the hydrogen policy. Kerala, as in Maharashtra recently announced one, there is one from Andhra Pradesh. So what it means, what does a hydrogen hub mean? It means that within a radius of, let's say, 100 kilometers, the production, the generation or storage as well as usage will all happen in the same location. So all the challenges that we have, we speak about pipelines and material and all those things, that could be minimized. And eventually the hydrogen economy can happen. So as Tubacex, we are contributing in all these areas. we are not only supplying our own products that are used in these areas, but we are also trying to ensure that we contribute in the right way. So that's what I wanted to share differently, and looking forward for your questions.
Thank you so much for flagging it so well, because, you know, all these hubs where you capture the hydrogen in those batteries, which will be used by auto sector, can happen then. So that, you know, then the transformation will happen, the manufacturing models are available, the size of batteries are available, and how they will do is available, but hydrogen is not available, you know. So that is where the story is today. So these kind of hubs is the futuristic way, and good, you flagged it so well, and where the government is moving and where the state governments are taking the initiative about it, because I see the first breakthrough in the auto sector, which will go, and then the industry sector will follow as we will go, and industry is all in readiness because they are using natural gas and they are looking for it. They are looking for an alternative which is indigenous. So they will be the first one to go in for it, and the rest will follow as we move ahead with it. So the market is geared up, the market is ready, the market is conscious for these alternative energies. We did talk about the oil, gas, which will be the first step. We will be moving and then graduate to hydrogen gas, and ethanol will be something which will sort of offset a percentage of it, not 100%. We are not looking for ethanol as an alternative. It will be maybe a two-digit, maybe one-digit percentage, 9% or 10% at the most. It can go in for. Not beyond that, even though there are lots of talks about it, but that's the level it will walk through, and that is how we will graduate into it. So I think I must thank the panelists and organizers. Do we have time for some questions? Maybe a couple of them, so we can have one or two questions in case there are any.
No, we'll try and restrict it to questions. No
By question, I mean
no
you can
statements.
add on also, and you can make your
questions,
observation. Over to you.
Just one question to the whole panel. I hope we are not going overboard by talking hydrogen and hydrogen. What I want to emphasize is there was a news item couple of months back that there is a controlled nuclear fusion has been achieved in United States. Maybe 4 years, 5 years down the line, you will not need hydrogen. So if you direct the economy so much in one direction, then you find that it has changed. It is so much of waste. I mean, there should be a thinking at the apex level on which direction the country should go. Hydrogen and hydrogen perhaps is an selling the idea, because we are following the European countries blindly. That's my sort of understanding of the situation at this moment. I mean, we should be talking a balanced view, not hydrogen all the time.
Actually, we have to see how we can utilize hydrogen for India. So we have a lot of waste, and we can attack two problems, rather three problems: pollution also, waste management also, and clean energy source also. So there is no harm in trying this technology which is now available in a matured way. What you are talking about, nuclear fusion, that will be the first plant which is expected to synchronize in 2028, and that is also a prototype for Microsoft data servers. So that company, whether it will be able to give that in 2028 or 2050, whatever, at this date we cannot just depend on that and keep ourselves disengaged that that will come and then we will see when it develops and whatever. By 2050, if world has to survive, we have to bring down our CO2 emission or GHG emission to such a degree that the temperature rise by the end of the century is controlled up to 1.5 degree from the pre-industrial level. Presently, it has already reached 1.2 degree, or it is reaching 1.3 degree. So we don't have much time. By 2030, we have to put this temperature rise in the downward trajectory. So there is no other way to decarbonize to the extent maximum it is possible from my side. I would say this.
Thank you so much for really hitting the bullseye. And here I like to say one thing, that India has never gone for nuclear and it will be only a source of energy. Don't forget, gas is also used for generating heat, right, in the industrial manufacture. So these will be two parallel sources, and a shift from the coal as an energy source or a calorie contributor. And that is how we are going to move ahead when we will go. Yes, we have to work on both the paths as parallel streams and then hit it which is economically viable, and we may require both as we move ahead. Maybe one more observation we can take, otherwise we'll close, right?
I think it looks like a close.
Right.
Just adding a bit to the dais, hydrogen is not a new phenomenon. It's been around for 50 years. Just that the new terminology, green hydrogen, as your path to carbon emission reduction is getting popularity now.
In fact, there's a color for nuclear hydrogen also. It's called purple or red hydrogen, which is the one from nuclear energy. So, and just to add in one more point, that we are also trying to replace the existing fuel form into hydrogen. So it doesn't mean that we're trying to find only hydrogen applications. The existing, like for example, I don't know if you have read, Tata Steel just put in hydrogen blending in their blast furnaces. So the existing coal which they were using, they're just changing that into hydrogen. So it need not mean that we are finding entirely new areas of application. So.
Yes, and I would like to close this by thanking each of the panelists who brought in very, very important issues, and all of them needs constant work and documentation when we are moving ahead. I would just like to end it with a small anecdote that all these sources of energy will be like, you know, the digital payment system, and you still have some people using checkbook, and you still have people going to ATM, and you still have people who go and fill the slip to draw the cash from the bank counter. So all are going to coexist. It's only a percentage of replacement as we grow into it. Thank you so much. Thanks. And I thank the panelists for sticking the time so that we started late, but we were able to catch up. Thank you so much. Thanks.